Hello and welcome to this video. As I have said in my previous video, we will start with arithmetic progression. So before we can deal with arithmetic progression, we learn a bit about sequences. So you can form a sequence like 1, 2, 3, 4, 5. So the rule is in this sequence is that 1, 2, 3, 4, 5, each number which is coming is greater by 1 from the previous number. So suppose our succession of numbers is t1, t2, t3 up to tn. If this is formed by certain rule, then this is called a succession. T1 is called the first term, T2 is second term, and Tn nth term. Alternatively, sequence is a function, specifically a discrete function, whose domain is set of natural numbers. Set of natural numbers is denoted by n or a subset of n. The domain is either n or subset of n, and range will be a set of real numbers. There are two different kinds of sequences, finite and infinite sequences. When you have finite number of terms in your sequence, it is called finite sequence, and when you have infinite number of terms in that sequence, it is called indefinite sequence. When we add these terms like a1, a2, a3 to an, it is called a series. Either by adding or subtracting the terms of sequence, you get an expression that is what we call as a series. Now, what is a progression is that for a sequence, it is not necessary to follow a pattern of formula for nth term, but when it does, we call it a progression. There are three different kinds of progressions: arithmetic progression, geometric progression, and harmonic progression. To begin with, we will deal with arithmetic progression. Like the example I gave 1, 2, 3, 4, the difference between consecutive terms is constant, that is 1. Similarly, you can have 2, 4, 6, 8, or 3, 6, 9. Any table which you have is basically an arithmetic progression. But the progression can be decreasing also, like 20, 18, 16, 14, and so on. So when you have this kind of sequence of numbers and you represent them with a plus sign, then it forms an arithmetic progression. Let's determine the nth term of an arithmetic progression, because it is called general term and a lot of formulas revolve around the general term of the arithmetic progression. So consider that a is first term of the arithmetic progression and d is common difference. That is the name by which they go. So our first term will be a. We can rewrite that as a plus 1 minus 1 into d, that is 0d. Second term is a plus d, because that has to be added to the common difference has to be added to the first term, so it becomes a plus d. We can rewrite that as a plus 2 minus 1d. Following this, you will see that nth term can be written as a plus n minus 1 into d. By analogy, we can write that. So that is the formula for nth term. Now, once we have found the formula for nth term, we need to find the sum of n terms of an AP. So we can write sum as Sn, sum of n terms, S for sum and n for n terms. First we write as a plus second term a plus d, followed by third term a plus 2d. We go on till tn minus 2th term. Tn minus 2th term will be tn minus 2d, followed by tn minus d, followed by tn. Next, what we do is we rearrange these terms and write them in decreasing order. So the second Sn here, oops, which you see here is the same progression written in reverse fashion. Now when you add that, you get a plus tn repeated n times. So the formula after that follows: Sn becomes n by 2 multiplied by a plus tn, and then we substitute the value of tn to get sum as n by 2 into 2a plus n minus 1 into d. So these two are very important formulas, and most problems in arithmetic progression will revolve around these two, except arithmetic mean. We will deal with the arithmetic mean, geometric mean, and harmonic mean later. First, we will deal with these two formulas and all the problems will follow from these two. Now, let's study some properties of AP or arithmetic progression. When you add a quantity or subtract a quantity, the resulting progression is also arithmetic progression. So in the table, you can see that, let's say our given arithmetic progression is a plus d, a plus 2d. Sorry, that's a typo. It should be a plus 2d over here. It is not a plus 3d. So, and Tn is a plus n minus 1 into d. If we add a constant k, then our series becomes a plus k, a plus d plus k, a plus 2d plus k, a plus n minus d into n minus 1 into dk. There is also a typo. So I'll correct these before putting it on GitHub. Don't worry about that. And if you subtract, then your series becomes a minus k, a plus d minus k, a plus 2d minus k, and another term becomes a plus n minus 1 into d minus k. So you see that all terms are changing by the amount k. So the first term changes to a plus k and a minus k, but the common difference remains same. Common difference remains d. So that's why the resulting series will also be an arithmetic progression. The other property of an arithmetic progression is that if you add two arithmetic progressions, then the resulting progression is also an arithmetic progression. Consider two different arithmetic progressions which have terms a1, a1 plus d1, a plus 2d1, and a2, a2 plus d2, a2 plus 2d2. Then if you add them, then the terms become a1 plus a2, a1 plus a2 plus d1 plus d2, and so on. So if you observe carefully, the resulting AP first term is sum of the other two, and the common difference is also sum of the two series which are added to get the resulting AP. So the common difference changes, the first term changes, but common difference remains same, d1 plus d2. That is why the resulting AP is also, that the resulting sequence is also an AP. Now the other properties of AP is that if you multiply or divide by k, then the resulting progression is an arithmetic progression. In this case, you will see that your common difference increases by a factor of k or decreases by a factor of k. And same applies for the first term. In case of multiplication, it increases by a factor of k, and in case of division, it reduces by a factor of k. So by using these properties and formulas for sum of n terms and the formula for nth term, we will solve a lot of problems. So in this video, I'll stop here. I'll implore you to download the PDF, and if you have liked this video, please like the video and subscribe to my channel, because that motivates me to make more videos on a particular topic. Thank you for watching. Happy solving the problems.